Hello everyone. In this video, this is part number 2 of the vertical shifts and horizontal shifts, where we're just going to go through a couple of worked through examples. So in the first video, we saw how to actually do it. So the first thing that we actually have to do is identify the parent function. So in this one, it's pretty easy to tell that this is the square root function. So this is the square root function. And if you just want to remind yourself of what that looks like, remember we have that little bullet point where we stop, we can't go past it, and then it looks something like that because we can't have negative numbers. That's why we stop at that little bullet point right there. So the next step after that is we need to identify our our shifts. So first thing I like to do is I like to look for something inside the function. Now with the square root, I'm looking underneath the house. I see that this is x minus 2. Remember that x minus 2 is when if we set that equal to 0, we find out that the x value is actually positive 2. So this is going to shift it in the positive x direction, which is to the right. So we're going to shift this to the right 2 units, which means for our key points, we're going to add 2 to our x values. And then I also see on the outside of the function that we have this minus 1. That's a vertical shift down of 1 unit, which means I'm going to subtract 1 from my y values. Next, I need to write down those key points and then adjust them. Okay, so let's write down our key points. Remember, it starts off with 0, 0, but this time we're not going to go into the negative inputs. We're just going to go positive. And we want positive perfect square roots. So the square root of 1 is 1. The next perfect one is the square root of 4, which is 2. And the next one that we can fit on our graph here is the square root of 9, which is going to be 3. So that's what we can fit for the parent function. Now let's see how many we can fit after we adjust them. So let's do our x values here. So we see that we are going to add 2 to our x values. So 0 is going to go to 2. 1 is going to go to 3. 4 is going to go to 6. 9 is going to go to 11. So we're not going to be able to graph this guy because that's going to be off our graph a little bit, but that's okay. And now we have to do our y values. We are subtracting 1 from all of our y values. 0 goes to negative 1. 1 goes to 0. 2 goes to 1. And 3 goes to 2. And now, lastly, we just got to plot our points and graph the line. So we're going to graph these new points here. Don't graph the original ones, graph the new adjusted ones. Let's do it in blue. So we have 2, negative 1. Oh, I forgot one thing. This 0, 0 right here, that is our bullet point. That's where we stop. So let's do this guy in black, actually. In black, 2, negative 1. That's where I stop. Okay, and then we have 3, 0, 6, 1, and 11, 2. And it's going to be like off over here a little bit. I just put that there just so I can have a better direction, better sense of direction where I'm going with this. Remember, this guy is curvy, kind of like a sideways half a parabola, if you will. All right, and that's the transformation of example number 2. Let's do it one more time and then we'll get out of here. So we need to move over here. All right. So this one's going to be a little bit tricky because this is a reciprocal one and we got some hypotenuses to discuss. Okay. So first thing that we need to do is obviously we identify that it is the reciprocal, which is 1 over x. That's our parent function. And if you remember, it looks like 2 boomerangs that are in the first quadrant and the third quadrant, or the upper right and the lower left of the graph. Okay, So next I need to identify my transformations. Remember, if I see this x plus 2 in the denominator, that is inside the function. So this is a horizontal shift. And if we x plus 2, if we solve that down for x, we see it's negative 2, which means I'm going to the left 2, which means I'm going to subtract 2 from my y values. Okay, now I'm looking for something on the outside. I see this negative 3, which is a downshift 3, which means I'm going to subtract 3 from my y values. Okay, next up we need our hypotenuses and we need our key points. Well, remember we have a vertical hypotenuse, not hypotenuse, what am I saying? A vertical asymptote. Ay caramba. A vertical asymptote. And this vertical asymptote is at the line x equals 0 because, as we know, the vertical line equation is always in the form of x equals. And then we have horizontal asymptote at y equals 0 because horizontal lines have the form of y equals. Okay? So now we need our key points. Our key points are going to be at -1, -1, and also 1, 1, which this makes sense because if you can't remember what the key points are, just plug in -1 into the parent function here. You have 1 divided by -1, -1. If you plug in +1, you get 1 over 1, which is just 1. All right, now we need to adjust these. Okay, so the vertical asymptote, that's an x equals. So we're going to follow what we're doing for our x values, which is in green here. So the x values get pushed to the left 2, or we're going to subtract 2 from our x value. So that means instead of x equals 0, now we have x equals -2. So we have a vertical line at x equals -2. I'm just going to draw that in right now. So that's our vertical asymptote. Our horizontal asymptote is going to do the exact same thing except for what we're doing with the y, which is down 3 or subtract 3. So now we have a vertical or a horizontal asymptote at y equals -3, which is going to be right here. So those are our new asymptotes. And now we do the exact same thing that we did before with our key points. So for our x values, we're going to subtract 2. So -1 minus 2 is -3. And then 1 minus 2 is -1. And then for our y values, we're subtracting 3. So this goes to -4. And then 1 minus 3 is -2. And then we just plot our points and go. So plot our points here. We have -3, -4, which is right there. And our -1, -2 is right there. And now remember when we're graphing this, we're going to start really close to the asymptote, but never touch it. Slowly build out, go through that point, and do the same thing. Get really close to the other asymptote line. And then the same thing up here. Slowly work your way out, go through the point, and then get really close to the asymptote, but never touch it. And there you go. That's to work through examples. I hope this really helps solidify your holes that you may have had. And as always, be safe and be healthy during this time. And I will see you guys in the next video. Bye.